Hello all and welcome to my YouTube channel. Welcome to the series of LangGraph. This is the fourth video in this particular series where we are learning the LangGraph in depth. So if you have missed the previous three videos, please go ahead and check out that. The link is available in the description below. In the previous videos, we have already covered the basics of LangGraph. Then we have covered the conditional graph. Also, we have covered the memory management in LangGraph. And in today's video, we are going to focus on the streaming responses in LangGraph. So let's get started with that. First of all, let's understand what exactly is the streaming. So streaming is nothing but showcasing these responses generated by the large language models to the users as soon as it is generated from the large language model. Meaning, large language model generates the responses in the format of token. So as soon as the token is generated, instead of keeping user waiting until the final response is generated and showcasing the complete response to the user on the generation of that response, instead of doing that, the large language model can directly, once the first token is generated, you can start giving that token back to the user so that user will feel more engaging whenever user is dealing or whenever user is chatting with the large language model. Let's see this example, how exactly the streaming works on the ChatGPT. So let's say if here I'm asking the question, let's say, tell me about India's growing economy. So you can see the moment I have asked the question, it has started generating the response. As you can see, it is printing the response token by token. This is nothing but the streaming response. It did not wait for getting the complete response and then instead of passing that complete response, keeping the user waiting for the response to come, it has started giving the response as soon as the model has generated that. And that is nothing but the streaming response. And that's what exactly we are going to see in this particular video. We are going to deep dive into that. We'll be understanding the basics of streaming and then we'll explore how exactly the streaming works in the LangGraph. In the LangGraph, there are multiple layers that we will be unfolding to understand this streaming in depth. So let's get started. So first of all, let's understand what exactly is the streaming. So streaming is nothing but generating the response token by token or piece by piece or word by word, right? Instead of waiting for the whole answer, we can show the tokens that are generated by the large language model. This gives the faster response for the user and which makes the user feel more interactive, and we can enhance the user interface. We can enhance the user experience with this. So this way your user will not feel boring while talking to the large language model, and user also will get a feeling that it is not a waste of time for user as well. As soon as the response is generated, user can start reading through it, right? So that's the main purpose of that. Let's understand some key points about the streaming. So first of all, what is streaming? This we have already seen now, incremental or token chunk emission generating from the large language model, and it is referred as auto-regressive model. Now, what exactly is this auto-regressive model? We'll cover that in a bit. First of all, let's understand why streaming, because it reduces the latency. It makes the UI more progressive as we are generating or as we are showcasing the responses or tokens as soon as it is generated. And this way, the early execution of output, user no need to wait for the complete output. User may get the response by just reading initial 4 or 5 lines and then user can quit, right? So that way you are saving users time. You are making the conversation more interactive. Let's understand how this model produces these tokens. Now let's get deep dive into that. We have seen why part now. Let's understand how. So for to understand that, first of all, it's important to understand what exactly is the autoregressive decoding loop. Autoregressive decoding loop meaning passing some input to the large language model. It is generating the response in loop. That generated response, again, we are passing to the model as an input and it is generating the next input. That is what is the autoregressive decoding loop. Let's understand this. So what exactly this model does, it looks for the context. Now context is nothing but whatever token that we have passed to the model so far, it collects that token and based on that it generates the response. Now these tokens can be one word, two word, or it can be a sequence of sentences. It depends on at which level you are passing the input to the large language model. And once you pass this context, it predicts the probability distribution of the next token. Based on the input that we have given, it tries to identify the probability for the next possible word. And based on that probability, it picks the probability with highest one, or there are other algorithms that we are going to see. And then it is going to generate the next token. And it repeats this particular sequence until the model is passing end of sequence or it is reaching the maximum length. Now, let's understand this with the help of simple diagram. So, let's say we have a large language model. It can be any model. It can be GPT model or Gemini model, any model. Now, let's say we have passed once as an input to the model. So based on this once, this is the context that we have passed to the model now. By taking this context, the model will try to predict next word and it has predicted upon. Now, how it has predicted? It has find out the probability. So let's say there are, let's say 1,000 words that the model is thinking of. Okay, these 1,000 can be possible next word. Now, based on the training that we have performed for this large language model, it will predict that. So based on, let's say in the training, if you have passed once upon type of sequences multiple times, so it will give higher probability for upon word, right, than the on any other words. So that's how it will predict that. Out of those 1,000 words, it will pick the one which is most suitable. So in this case, let's say it has selected upon. Now next time, the context will increase. Now the context will be once plus this particular upon. That is what we have passed. And this input will go to the large language model, and then large language model will generate the next prediction. So let's say it has generated A. Now we will pass all the three together and then we'll request model to generate the next word. So it has generated time. So the final response is once upon a time. We have given these words in the sequence so that model can predict the next output. This is nothing but the autoregressive or autoregressive decoding loop. Let's see why these particular words only and why not others, and how to choose these particular words. So there are different ways with which we can wisely choose these particular words. So let's understand those strategies first. So this strategy works based on the probability distribution over the possible next tokens. So let's take an example. Let's say we have a example once upon A. This is what we are passing to the model. Then model predicted these four words, let's say time, day, kingdom, story with these probabilities, right? The highest probability is with time. That's where the model has predicted time. Now, how model is selecting that? First method is greedy decoding. Now, this greedy decoding is a method which always selects the one with highest probability. No matter how many are there, whatever is defeating the other words, it is going to select that particular word. In this case, it has selected time. That's how the next word prediction is time. Next algorithm or strategy is beam search. As its name suggests, beam search meaning it is kind of a laser focused one which explores the multiple candidate sequence in parallel, and out of that it picks the overall best one. So again, in this case, it will pick time, or based on the parallel execution that happen, it will select others as well based on the structure. The next one is the top case sampling. Again, not widely used. Let's say here you are setting k value as 2, meaning it will pick the top two tokens. So in this case, it will pick time and day. And again, this picking is again randomly. It can pick based on the probability, or it can pick it based on the randomness. So that depends. So that's where this particular top sampling is not that popular. The next one we have is the top P nucleus, which is a sampling method, basically where you need to define the probability value. Let's say here we have defined 0.9. So what it will do, it will pick the number of tokens or number of words with the minimum words. Like you can see the smallest set of tokens which are going to defeat this particular probability. So let's say in this case, we have time and day. If you combine the probability of time and day, it is going close to 0.90. So in this case, it has selected this as a two words. So that's how the sampling works. So in this case, output may be time or day. So that's how it works. And the last one we have is the temperature. And again, now temperature is, you might be already aware about the temperature part. So temperature is nothing but which controls the randomness in the sampling. So if you are setting 0.1 as temperature, meaning model will focus more on your actual answers. It will not add any randomness. But if you set temperature as high, then your model will add more randomness. Model will add a model will think, not only think from one direction, but model will try to generate the generalized response, and in this case it may come up with day, kingdom, or story as a next word. So that's how this thing works. Now this is the overall basics of streaming. Now let's understand how the streaming works in the LangGraph. So for that, first of all, let's go ahead and build a quick simple graph structure. We will test that. Once it is working, then we will go ahead and see how that streaming works in the LangGraph. Okay, so first of all, let's go ahead and add the dependencies. So here I'm adding the dependencies. So we'll be requiring LangGraph, LangChain OpenAI, and LangGraph SDK. So let's install those dependencies. Now, I'm adding one optional code. In the previous videos, we have used this particular code in order to use the large language model. We used Gemini model. So if you want, you can go ahead and use this particular code, but it is optional. As I want to cover other models as well, that's where this time I'm going to use Azure OpenAI. So what will be the code for that? Again, it is simple. We'll be importing that from LangChain OpenAI. So this is the simple code for that. We have used LangChain OpenAI. From that, we have imported the class Azure Chat OpenAI, and from LangChain.prompts, we have imported the chat prompt template, which is again common in Gemini as well. For Gemini, we have imported it from LangChain Google GenAI. Here we have used it, read it from the or loaded it from the LangChain OpenAI. Then we need to set these two variables: Azure OpenAI API key and OpenAI endpoint, and then model parameters we need to set. So like the Azure deployment name, API version, and temperature. So first of all, let's go ahead and see how we can grab these particular keys. So let's go to portal.azure.com. If you are new to this particular one, you need to create one account on the Azure, and then you need to create a subscription. You can select your free subscription if allowed. So I have selected pay as you go service. So this is the service that we are going to use, Azure OpenAI. Let's click on that. Let's quickly create the service. So click on create OpenAI. Resource group name, let's give name as RG OpenAI. Then service name, let's give it as OpenAI LangGraph. Pricing tier, let's select standard, yes 0. Let's hit next. Resource group, sorry, we need to create new RG OpenAI. Okay, hit next, next. It is running the validation steps. Once the validation steps are completed, we will go ahead and create the service. Okay, validation is successful. Let's click on create. It will create the service. And if you are new to this particular Azure OpenAI deployment, I would highly recommend go ahead and check out my YouTube channel. I have covered these details in depth on my YouTube channel. So please go ahead and check out that. So the deployment is currently in progress. Let's wait for the deployment. Okay, as you can see, the deployment has been completed. Let's go to the source. Let's click on Explore Azure OpenAI portal. So we are going to the Foundry portal, and from Foundry portal, we'll go ahead and deploy the model. Again, if you are new to this, I would again recommend go ahead and check out my YouTube channel. So again, in the deployment sections, we can go ahead and deploy the model. So we'll be using GPT-4 model. So let's select base model and search GPT-4. So you can see wide variety of models are available. Out of that, we'll be using GPT-4o chat completion. So let's select that model. And under the customization, let's reduce the token. 45K is not required. I think 5K is more than enough for our use case. So let's deploy this. Okay, so deployment won't take much time. So within 5 seconds, you can see the model is ready, and we need these details. So first of all, we'll need the OpenAI endpoint. So this is the GPT-4o model. You can see the configuration details. So we have copied the key. So let's go ahead and enter the endpoint, and also let's go ahead and copy the key. So this is the key that we will be using. So copy this key, and I'll add the key here. So I'll go ahead and delete the resource group that I have created. So all the resources I'll be clearing out before uploading this video. So make sure you are not exposing your keys. Okay, let's go ahead and execute this. Okay, OS is not defined. That's fine. Okay, so we are able to load the model. Now let's go ahead and build the simple graph. So I'll quickly add the code to build the graph. Again, it is very simple. If you have missed the previous videos, I would recommend go ahead and check out those. So I have added Google OpenAI as well. So with this, you can generate this model, right? I have covered the Azure OpenAI as well. If you want to use OpenAI service, you can use this particular part as well. You just need to set the OpenAI key that you need to pass. So I have covered these three wide variety of range that you can cover. Let's focus on this particular part now. Now here we have imported the dependencies like from LangChain OpenAI, Azure Chat OpenAI that we have already imported. Then LangChain.core, we need human message so that we can pass human command to our graph. Then we have imported state graph, start, end, and message state in order to build the graph state, and checkpointing in order to add the memory. So this memory part we have already covered in depth. And then we are defining the state. This is again very simple. We are just defining a message type, which is again in the simple format. Then conversation node we have defined because we will be building this graph flow. Let me execute so that it will become very clear. Okay, so this is what we have built: start, then the conversation, and then ending the conversation. So this is the simple workflow. State graph, the class that we have imported from LangGraph, which is giving us or setting up the workflow for us. And in that workflow, we are adding conversation as a node, you can see. And then we are adding edges, which is connecting start to conversation and conversation to end. Very simple workflow. We have added a memory saver, and we have added this memory saver into the checkpointer so that it can go ahead and compile that. So this graph is ready for us. Now, let's understand this streaming in LangGraph quickly, how exactly it works. So there are two methods available: stream and asstream, which is similar to the sync and async. Sync meaning the operation that runs in sequence, async meaning the operation that runs in parallel. So you can use any method. Okay, now there are two main streaming modes that are available: values and updates. Values means it streams the full state of the graph after each node runs, and update meaning stream only the changes, the delta after each node. Let's understand this with the help of this simple diagram. Let's say you have three nodes built in your graph structure, and the conversation is happening from node 1 to node 2 to node 3. Now, if you are using the streaming mode as update, it will only give the latest output. So you can see, let's say if the model is generating response as high, it will only give the output as high. If the next word, it will, for the next node, it will only give the response that, okay, I am iTech bot. That's the response that it has generated. And at the last node, it is giving that, okay, how can I help you? So it is not collecting the responses from previous states. So each node here, you can consider it as one state. So this values is a type of state in which update is a type of state in which it is only giving you the last output. If you are putting the mode as values, then it is accumulating the results. So first, the response was high for the first state. For second state, the response is I am iTech bot. iTech is our YouTube channel. So if you are new to that, please go ahead and subscribe to my YouTube channel. In the node 2, it is collecting the response from node 1 as well as node 2. And similarly for node 3, it has collected the response from all the previous nodes. Hi, I am iTech bot. How can I help you? So that's the basic difference between update and values. And this has its own meaning. Why we are learning that? Because this is the main criteria for streaming. Based on this, the streaming is dependent on. So let's see first how exactly the streaming mode update looks like. Let me add a few code steps. Okay, let me add a simple code. So we have already defined graph state. So from that graph.stream, you can see we can pass message as, let's say, tell me a capital of France in one line. Configuration is this configuration where we have defined the thread. Now thread is nothing but the channel on which we are capturing the conversation history. So all the conversation history that is going to happen will be captured on the thread. And then streaming mode, we have given updates. The first mode that we are seeing is update. Let's see how exactly it works. Okay, you can see it has generated the response. The capital of France is Paris, along with some other metadata, that how many tokens it has used, what was the prompt token, the total token, and the completion details. It has added model details. Then it has added some filtering condition. You can see content filter to check the abusive content, the sexual content, all those details it has added. It has added the filters to check whether the response is safe or not, or whether is there any self-harm content available. All those details it has checked. So that are the other metadata. Let's not focus on that. Our focus is to check the streaming response. So it has given this response and currently it is in streaming. But how to check that? We'll see that quickly. So in order to check that, out of this, we just need the conversation, and from that we need the message. So let's pick the message, and then we are adding pretty print. So pretty print is again similar to print, but it prints in better way. So let me show you that. Okay, so it has, you can see it has generated the AI message as the capital of France is Paris. It has only given one liner output, the final output that it has generated. It is not accumulating the responses. Fine. Now let's see whether the values mode equal to values is accumulating the result or not. So let me go ahead and simply add the code. Okay. So I have added another thread ID so that we can maintain the conversation history on another channel, just to make sure that it is not mixing up with the previous state. Again, we have asked the question, tell me the capital of India in one line. And out of that, we can see we have captured the event. And out of that event, we have captured the messages, and mode we have given it as values. Very simple. And then we are printing it, and we have added some dashes in order to segregate the response. Now the first time if I'm executing, you can see 3 messages it has inputted. In human message, the message that I passed, tell me the capital of India in one line, that message was the first state. You can see this first state, the message that human passed. Second state, the tell me the capital of India in one line, the first response plus the response, the capital of India is New Delhi. So here you can see hi, that is the first response and the second response. As we just have 2 nodes, it has given this. Let's say if I'm executing this for, let's say, Paris. Now it has conversation, more than one conversation on same thread ID. So if I execute this again, you will see a lot of conversations now. Okay, you can see the first one was this, the response of first one, the second one, and in that second, again it has repeated the first responses and then the output of second, meaning how repetitive it is with modes as values. So I hope the basic difference between the update and values is clear now. So this is the streaming response that we have seen to understand how the streaming happens at state level. State level meaning at each node level. In LangGraph, we have this feasibility because we are building graphical structure. That's where we have the feasibility to see the streaming operations happens at graph level. So now this graph, you can imagine how exactly it is transferring the data from one graph to another node, sorry, one node to another node in this particular format. And that's what we have seen as well, right? Now let's understand how large language model generates the token. This streaming was with respect to nodes, but how the LLM is generating the token. Whatever exercise we did on this particular chat GPT, this we have called GPT-5 model, right? And GPT-5 model gave us the response in token by token. How exactly that happens? Let's deep dive into that. Okay, so for that, let's see this. We can use this particular method, a stream events, which stream back events as it happens inside the nodes. And each event is a dictionary with few keys. These are the dictionary. We have event, which is a type of event that is being emitted by the LLM. Name, this is the name of the event. Data associated with that event, and metadata, which contains the LangGraph node, the node emitted at the event. And let's see how this works. So for me, okay, so let me go ahead and add a simple code here. So here we have created new thread ID now because we want to test the new thing. And here I'm asking again same question, tell me the capital of France in one line. And here you can see graph.astream events. In order to check the streaming tokens of LLM, we have used astream events method. And then out of messages, we are picking the input message. Configuration we have given as this thread, and version we have passed. You can pass any version. And in the printing, we are printing the metadata and LangGraph node, as well as we are printing event and the name of the event, type of the event and name of the event. Let's print this. So, okay, you can see now how exactly the conversation have happened. Initially, it has started. So the node, nothing was there. Type on chain start, name LangGraph. Then node is conversation node. After starting the conversation node and the ending node. Now in the conversation node, the type is on chain start, name conversation. Again, conversation on chat model start and the Azure OpenAI. Now you can see multiple conversations for Azure OpenAI, and then it is ending. You can see end on chain end, and then it is ending the conversation. So that is the different states it has followed, or the model has followed. Now out of this, what we want is we want these states for Azure Chat OpenAI. That is our large language model. So let's filter out those states quickly. So these states we can filter out by using this particular event of metadata of LangGraph node. So let's go ahead and do that. So first of all, let me show you the complete thing. What is there in the event? That will become more clear. So let's execute this. Okay. So as you can see, if we are printing all the event data, then in that it has captured the states level streaming as well as the model level streaming. So you can see the node level streaming. First, we have passed tell me the capital of France in one line. Then, okay, this was the input message that we have passed. Then in the chunk, AI message chunk, initially you can see empty message, nothing was generated. For second also empty message. then chunk AI message, the, only the. So these states that you can see, right? What is happening in these states? That is what we are seeing. So the, then it has predicted next word as capital, then of France is Paris, and then ending the chain. And then these are the states messages that are for the, then these are the other configuration, like final response, what exactly it is generated. You can see the capital of France is Paris. This was the response that is obtained at this particular end level, right? But what we want is, as soon as the model starts printing, we want these steps to be plotted at the end for the end user, and that is what we are going to obtain out of this. So to obtain that, let me just quickly add a simple code. Now again, we are starting new thread because we don't want to hamper the previous one. Now out of this, what we need is, we need the conversation, because the node type for Azure Chat OpenAI is conversation. So that's what we have given here. Node to stream is conversation. And then this simple is a stream method, and same configurations we have given, same question we have passed. And here event is on chat model stream. So this one on chat model stream, that is the type we have given. And metadata, event of metadata dot get LangGraph node, and that LangGraph node should be equals to conversation, because we want to check for model only. So this filtration we have applied, node equals to conversation, type equals to on chat stream. So it is going to give us this particular metadata. So this will predict, this is this will predict the capital of France likewise, right? So let's see that now. And then we are printing the event data. So let's go ahead and execute this. Okay, you can see out of this, it has predicted only the one with respect to AI messages. And you can see the capital of France is Paris, and then end. Now out of this, let's pick only the content out of this. So to get the content, let me quickly add the small code. Again, we have started new thread because we don't want to mix our responses with older thread. So here out of that, we have filtered out the data, and from that data, we are only selecting the chunk, and then chunk dot content. Out of this chunk, we are only picking the content. You can see out of chunk, we are dot content, and we are adding a separator as end with space, meaning space as a separator. Let's go ahead and select that. Okay, tell me the capital of France in one line. You can see the space capital of France is Paris. But you might be worried, oh, where is the streaming response in this? As the response is very small, like only 4-5 words, that's where we could not see that. Let's ask some interesting question. Okay, instead of tell me the capital of France, let me ask the question, tell me about France, and let me remove this one line. Now you can see that how the streaming works. Okay, you can see capital of France, and it has generated. Let me add some more, France and economy. Let's see. Okay, you can see how exactly it is generating the streaming response. You can see this is the streaming for LLM, not for the node. Agreed? We are able to prove that how exactly the streaming works for the large language model. Now, I'm damn sure now you are aware how exactly we can integrate this. If you want to build any AI application, and if you want to enable this streaming, you can easily go ahead and implement that if you are using the LangGraph, right? So I try to cover that, the basics of this streaming. And as if you want to stream the nodes, you can stream that nodes as well. Here we have seen that example with update and values. There are a couple of other methods available. You can go ahead and explore that if you are interested, but these two are the main one. And also we have seen the streaming of LLM, right? Behind the scene, there are multiple things that are happening. We have filtered those and we have picked it, and this is how the streaming response works. So here also it was streaming, but as the response was very small, that's where we could not see that. And at the end, you can see we have clearly seen the streaming response. Let me show you that once again. You can see it is generating the streaming response. So yeah, I hope this was helpful for you. If you like the video, please go ahead and like the video, subscribe to my YouTube channel and share it with your friends. And also, if you have missed the previous videos, go ahead and check out that. And please feel free to explore other videos on my YouTube channel. The link is available in the description below. And yeah, we'll continue this particular series, and please stay tuned for the next interesting video in this particular series. Thank you so much, and I'll see you soon in the next video. Thank you.